Okay, so 8.3. 8.3. Now we're dividing them. You've seen the pattern? It'd be very simple to write an algebra book. Well, sort of simple, sort of hard, but the pattern's simple anyway. Basically, every chapter, and this is the square root chapter, takes up a new kind of thing, like I said in this chapter, square roots, and you see how to add them, subtract them, multiply them, divide them, simplify them, and then put them in equations, and finally with word problems. So that's exactly the pattern we're going to have here. So last section we multiplied them. Now we're going to divide them. And after this comes adding and subtracting the square root. So how do you divide? What are the rules for dividing a couple of square roots? How do you do it? Can I just come in here and just go 10 into 99 times like that? Just divide the numbers regular? Yes, actually you can. That's totally fine. Just go ahead and do that. Since they're both in roots. Now, if one of them was not in a root, like if it was plain 10 in the bottom, not in a square root, you know, then no, you can't divide 10 into 90. If one of them's in the root and one of them's out of the root, they're in different worlds, then that's not allowed. But yeah, if they're both in square roots, you just do it, but the result is also in a root, right? So 10 went into 90 9 times, but it's square root of 9 because it came from stuff in a root, right? And then square root of 9, 3, done. That quick? Just like that. Yeah, just divide them, root them.
Square rooting until you can't square root no more?
I only square rooted it once.
Huh?
You said keep square rooting it. I only square rooted it once. So notice I just divided. The first step was dividing. It wasn't rooting. So the first step was dividing. I divided, and then I square rooted on that. All right. So square root of 65 over square root of 13. Try that one. So use your calculator. See how many times that goes in there. See if it's divisible. So 13 goes into 65. How many times? 5 times. So we have the square root of 5. Now, can you square root 5? No. So we just stop right there. There's our answer. So we can't square. So the 5 does not, the root does not vanish. The root stays because we couldn't root it. Whereas last time, I got the square root of 9, so the root vanished because I did the root. Whenever you do the root, then the thing comes out and the root's gone. Right? So I did the square root of 9, and the answer was 3, no more root. But on this one, I can't root the 5, so the root just stays there on the 5. Done. Is that good? Does that make sense? All I did really was divide the numbers, really. And I could not lose the root. I could not do that because you can't root 5. All right. So square root of 50 over the square root of 200. Try that one. So I would divide those numbers. Start by dividing. 50 goes into 200, right? How many times does 50 cents go into $2? 4 times, right? That's what we have it there. 50 cents into $2, right? It goes in there 4 times. So now, where's the 4 going to end up, though? Top or bottom? Bottom, because the bigger number's in the bottom. 50 goes into 200. 200 doesn't go into 50. So the 4's in the bottom, but it's not a 4. It's a root of 4. Nothing's left on the top. What do we always do when there's nothing left on the top in a fraction? Put a 1. Okay, now the root of 4 on the bottom. What is the root of 4? 2. And the root vanishes this time because you can root the 4. You can do the root of 4. And it's just 2. Just a nice clean 2. So no more root when you can root the number. Is that good? Is that making sense on that? Right. We'll do this one more and we'll take a break. So what do we got? Root of 48y to the 3rd over the root of 3y. Try that one. You can just start dividing the numbers and subtracting the powers right now. 3 goes into 48. Subtract the powers. Y to the third over regular y is y squared, right? So go ahead and do that, and then do the rooting afterwards. So 3 goes into 48 16 times. And y to the third over y to the first is y squared. So we end up with root of 16 y squared at first. Right? I haven't rooted yet, but I've divided and subtracted powers. Is that good so far? And then what's the square root of 16? It's just 4. And the square root of y squared? Just cuts the power in half. Do 2 y's in, 1 y out. There we go. Plain 4y. No more root. Why not? Well, because the root did the root on the 16, did the root in the y squared. When he does his job, he leaves. Right? So there we go. Just plain old 4y. Which means what? All this big mess, that's a fancy way to write 4y. We just boiled it down to just a nice simple 4y. It's the same as 4y. That whole big mess is the same as just 4y. Is that good? Questions? All right, we'll take a break on that note there. All right, shall we pick it up and push on to finish 8.3, and then we'll start 8.4? So what about the square root of 1 over 81?
1/9.
Yeah. There's nothing to it, right? Just square root the top, square root the bottom. That good? Everybody good? The square root of 1 is just 1? Because what times itself is 1? 1 times itself is 1. All is well? Okay, so square root of 160 y to the third over the square root of 10y. All right, so try that one. What should you do first on that one? Yeah, divide the numbers, subtract the powers, and then do the rooting afterwards, huh? So first divide the numbers, subtract the powers, do the rooting afterwards. All right, so we divide them. 10 goes into 160 16 times. Is that good? And then you subtract the powers, it's y squared. And then you root afterwards, it's 4y. Easy? Make sense? All right, I'm going to move on if you're okay with that. In things right here. All right. Square root of 11 halves. How do we do it? You could write that if you want, it doesn't really matter, as 2 separate square roots. I'll just say or, either way, it's the same thing. 2 separate square roots or 1 big square root. It's the same either way. It doesn't really matter. Same thing. Anyway, so what can we do? Can we divide the numbers? Well, we don't want to make decimals. They'd be decimal, right? We don't want to go to decimals. So 2 doesn't really go into 11, not evenly. Okay, can we square root them? No, we can't do that either. We can't square root 11. You can't square root 2. They're not rootable. So are we just done? Is there just like nothing to do? No. They're giving us some particular instructions up here. Notice the words. They say rationalize the denominator. That means no square root, or get rid of, let's put it that way. Get rid of root in the denom. Get rid of the square root from the denominator. We don't want to have a root in the denominator any longer. So how do we do that? How do we get rid of the root from the denominator?
Times it to the top
Times it to the top
and bottom.
and the bottom? Do we have to?
Yeah.
Why?
Because you're trying to rationalize the denominator, right?
No, what I mean is, would it be okay to just multiply it on the top only?
No. Because you need to multiply top and bottom when you're doing anything like that.
Why?
I don't know.
I love what you're saying, and I want to talk about that for just a minute. So I'm supposed to get rid of the root from the bottom, right? Could I just multiply by the top? Wouldn't that work? Wouldn't that work? Root 2 would just cancel. It's gone. Root 11. We got rid of the denominator.
That's another way.
Is that okay? No, that's not okay.
Okay.
Why? Why not? What's the problem with it? So I think it's worth talking. I'm not just being silly or goofy or something. For a minute. I think it's really important that you really come to see, not just, I don't want to just stand up here and do math, monkey see, monkey do, because it won't help you as much that way. If I just say, here's the steps, do these steps, you go, yes, Mr. Heron, I see those steps, I'll do those steps. There's just too many stinking steps in math. I mean, there just are. It's way better if you get the why. Because of this. Then you'll know about 1,000 steps in 1,000 situations correctly if you really get the why. So let me really help you to arrive at the why. Why is that not the right step? And then we'll think about what is the right step. Why is that not the right step? Why? What's fundamentally wrong with doing that? Why? I know that's what we keep saying. You can't just do the top. You've also got to do the bottom. Why? Haven't I done that sometimes? Oh, because there's no equal sign? Yeah, even though I wrote an equals, you're right. There's not a left and the right. I'm not doing the left and the right of the equal sign. Well said. Well said. Yeah, you can. Yeah, as far as, because we do that sometimes where we just do the top, but you're right. It's only when we have an equal sign and we do the left side, and this equal sign doesn't count. We're just saying, maybe I should get rid of that. It's really that, right? It's not equal to anything. And I like what you're saying. That's a good point. The only time we can do just the top is when we do the left and the right of an equal sign. I can't do just the top here. It would be wrong. Why? I mean, you're right on the money.
It's kind of like the half of something and half of something making it like a whole, right? So you would have to multiply two things to make it one thing because it has a square root. So since you're trying to get rid of the square root of 2, you want to multiply them both together to make it a whole, which is going to be 2 in the end. But then you also need to multiply the top as well with 11.
So what? So you're giving some good answers. You're right. Those are going to be the final answers. You're right on the money. But why do I have to do it that way? Why is this not allowed? Why do I have to multiply the top and why do we have that rule in math that you've got to do the top and the bottom? Simply put, excellent said. It'll change the number. Yeah, what they're not saying, they're saying get rid of the root, but what they're not saying is don't change the value. Right? You with me on that? This is what we're doing all the time in math, is we're making the thing look different without being different, right? So in other words, I can't do this. Oops, get rid of this here. Come on. And let me go back to the way it was. Yeah, you're totally right. I'm going to multiply top and bottom. You guys know what to do, but I want to make sure you know why. Because that way, what is square root of 2 over square root of 2? Just itself. Just this thing. What is this thing? It's a 1. Same thing over itself is always 1. So I'm timesing by 1. Do numbers change if you multiply them by 1? No. Multiplying by 1 does not change. If I take 17 and I go times 1, it's still 17, isn't it? But what if I go times 236 over 236? whatever, that's 1. Still going to be 17. You with me? So if you multiply by a fancy 1, you don't change the value. That's why we got to do the same thing over itself. That's why we got to do top and bottom, because then it's a fancy 1. And multiplying by 1 doesn't change the value, right? So we can't change the value, we're just changing the look. That's why I use the word plastic surgery. I'm trying to use weird words you don't normally hear in math, right? So you remember, right? Removing the wrinkles, same person coming out the door, right? Same value, looks different though, right? That's what we're doing. We're removing the wrinkles. We're doing plastic surgery. That's so much of what we do in math. If you get that idea, you'll know what to do in 1,000 situations. That's almost always what we're doing. You know, we're making it look different without being different. So yeah, that's why we got to do top and bottom. Good. All right, so let's do it. So let's go straight across the top. That's just root 22. Nothing real important there. Just 2 times 11, 22. Still in a root, you know. What about the bottom, though? What about root 2 times root 2 on the bottom? Good job. Just plain 2. Why? Because there's 2 2's in, huh? So 2 in, 1 out. Everybody good with that? That's the fundamental rule of the whole chapter. 2 2's in roots, 1 on the bottom, 1 out. No more root in the bottom, so we did it. What did we do? We got rid of the root from the bottom. See, there's no more root in the bottom. By putting 2 of them down there, 2 in, 1 out. Good. And we can't divide these because these are in different worlds. 22's in the jail, 2's out of the jail. A root's like a jail, if that helps. Whatever, in, out, no interaction, right? You can't go to visit the local jail and go inside and socialize with the prisoners. They don't let that happen, right? So 2 different worlds, no interaction, done right there. What did we do? Got rid of the root from the bottom. You guys have a calculator? Can you tell me what is the root? Oh, well, let's go back to the first. What is the root of 11 over 2? I mean, you know. The original one was this, root of 11 halves. Let's go back to that one. What's the root of 11 halves? Somebody have that? Should be 2 point something. 2.345, blah, 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 goes on forever, huh? Okay, now do this one for me. What's the root of 22 divided by plane 2? The root, our answer, you know, the root of 22.
3.3166. Oh.
So the root of 22.
Oh, I'm sorry.
So only the 22 is the root. Try it again. Only the 22 is in the root. The 2 is on the outside. So try root 22. Get that, which would be 4 point something. And then divide by 2. Getting that? Did you do root 22? Well, what does it show you when you do root 22?
Do it again, sorry.
Oh, so yeah, you guys, you can't, the 2's not in the root. So what's your calculator look at? What kind of screen you have? So it's root of 22 and then divide by 2. But that 2's got to be outside the root, not in the root. So if you have, I think they usually have parentheses. So maybe calculate like this, root 22, close the parentheses, divide by 2. Like that. Should be 2.345.
Yeah.
Getting that now? Good? 2.345? Excellent. Yeah. Does that make sense? That way, because otherwise, if you don't do that, the 2, you're putting the 2 in there. If you don't close the parentheses here, if you leave them off, then you're telling that you're rooting the 2 is in the parentheses, in the root. I'm sorry. You don't want that. See the difference? Anyway, notice they're the same value. I just wanted to again emphasize we didn't change the value. It started off 2.345, ended up 2.345. We only changed the look. We made it look different, huh? No more root in the bottom. Is that good? That's so much of what we're doing in math and why we do. That's why we're always keeping the balance. That's why we do same thing top and bottom. If we don't have an equal sign, if we do have an equal sign, we do same thing left and right, huh? Because we can't change the value. All right. Good. So they're never, ever going to want you to leave roots in the bottom. So, any other math classes you take. So, let's try this one. Root 3, we're here, let me just write it the way it was. Root 3 over 28. You know, the first thing I would do on that one is break down that 28. That 28 has some pairs, right? Break it down. 4 times 7. 4 is 2 times 2. Ship out a 2, right? Do that first. So break down the 28 and do the 2 for 1 ship out thing first. So the 28, 4 times 7, 2 times 2. So 2 2's in, 1 2 out. So you guys getting root 3 over 2 root 7? Is that good so far? Are we good? Now, we cannot leave the square root in the denominator, right? Otherwise, we'd be done, right? We did the 2 for 1 chip out, but we cannot leave a square root in the denominator. So how do we get rid of that square root from the denominator? Yep, and top and bottom, so we don't change it. That's a fancy 1, right? We're multiplying by 1. We're not changing the value, but we'll change the way it looks. Remove the wrinkles. Remove the root from the bottom. So try that. So the top is just 3 times 7, root 21. The bottom is 2, and then root 7, 2 7's in, 1 7 out, a plain normal 7, and then 2 times 7, 14. And we're done. Root 21 over 14. There we go. Good on that. Questions on that one? We happy? All right. Okay, so number 13. So root of x squared over 27. Try that one. So break down that 27, do the 2 for 1 chip out. So 27 is 3 times 9. The 9's 3 times 3. So breaking down that 27, 3, 3, 3. So 2 3's in, 1 3 out. And on the top, 2x is in, 1x out. Am I going too quick so far? We're not done yet, but so far so good. Right? The 2 3's in, 1 out, and this extra 3. Whoops, I'm not supposed to erase them. This extra 3 stayed in. And the 2x is in, led to 1x out, no more root in the top. But now we can't leave this root in the bottom. Got to get rid of it. One more step, right? Multiply top and bottom by root 3 to get rid of it. Top and bottom by root 3. So we get x root 3 over. Now, root 3. These two make a plane 3, so it's 3 times plane 3, right? These two make a plane 3. This 3 was already here. Does that make sense? So it's 9 on the bottom, isn't it? It's x root 3 over 9. Does everybody see that? Everybody see what happened? Are we happy about that? Why can't I go 3 into 9? Yeah, different worlds. In the jail, out of the jail. No interaction. Right? So there we go. Questions on that one? We good? All right. All right, so try that root 3 over root 250. So break down that 250. So first break down that 250, right? Ship the pairs out. That 250 is 25 times 10, right? 25 is 5 times 5. 10 is 5 times 2. That good? Break it all the way down. And then ship out what you can ship out. 2 for 1. So 2 5s in, 1 5 out. What's left in? 2 times 5, 10. On the top, root 3. Good so far? Everybody see what came out, what stayed in, all that? Now we can't stop there. We got to get rid of the root from the bottom. But is that good? So 2 5s out, 2 5s in lead to 1 5 out, and then a 5 times 2, 10 stayed in. Okay, we cannot leave that root in the bottom. Got to get rid of that root from the bottom. So now we multiply top and bottom by root 10, right? Is that good? And then on the top, 3 times 10, that's root 30. On the bottom, the 5 stays here, and root 10 is a plain 10 out, right? Those 2 10s in, 1 10 out. So it's root 30 over 50. We got it. Got rid of the root from the bottom. Good. Questions? All is well? All right. So square root 432 over root 12. 432 over root 12. Those are divisible, aren't they? Just use your calculator. Try 432. Don't break them down. Just always try dividing first. Always try dividing first. In this case, I think that goes in, doesn't it? 20, 25? 36. So 36, okay. And it's right, this goes into that 30, so 12 goes into 432, 36 times. Root of 36, 6, done. That quick. So always try to divide them first. That's the easiest thing to do. If they divide, if they reduce, do that first. If they don't, then go on to other stuff. That good? That'd be easy. Say it again. Oh, where you want to get rid of the root from the top? No, it's only the bottom. See how they say rationalize denominator? Yeah, good question. Only the, we're fine with square roots in the top. We don't care. Leave them. We're happy. We're not fine with square roots in the bottom. Yeah, it's just the bottom. We just want to get rid of square roots from the denominator. Yeah, try that one. Got to get rid of that one. So like I was saying in the last problem, first try to reduce the fraction. Yeah, so always do that first. So you can divide top and bottom on this one, right? Before you do any fancy stuff, just reduce the fraction. Divide top and bottom by 5, or you can even do 25, huh? Divide top and bottom by 25, and reduce that fraction, then go on to the other stuff. Be a lot easier that way. So I would divide by 25. Top and bottom. So you get root 3 over the root of 10x. Is that good? Root 3 over root 10x? Now, get rid of the root from the bottom. And how do we get rid of the root from the bottom? Multiply top and bottom by root 10x. Is that good? So what happens on the top? Top, you just multiply them together. No big deal. Root 30x, who cares? The bottom, you got 2 10s in the root, 1 10 out. Got 2 x's in the root, 1 x out. There we go. Is that good? See how we got a 10x out of the root on the bottom? Because we had 2 10x's in? Like that? That good? And why can't I cancel any of this stuff? Like the x's or the 10 into the 30? Yeah, different worlds, right? In the jail, out of the jail. In the root, out of the root. Different, no interaction. Different worlds. Just leave it like that. Good? All is well? All right. So square root of y to the 17th over the square root of xy squared. So first thing on this one, I would subtract those powers. Subtract powers first, right? Simplify the fraction whenever you can first. Subtract powers, and then get rid of and then do any 2-for-1 shipping out. Then get rid of the root from the bottom. Kind of save that for last. So is this making sense? So I would go y to the 15th over root x, just 17 minus 2 is 15, first off. And then what do we do with an odd power? What are we going to do with that? What we always do with odd powers? Make it even with one more. So we say, okay, so this is y to the 14th and one more. And then we've got 14 y's. 2 in, 1 out, huh? It's a 2-for-1 deal, right? So if we got 14 y's inside the root, then that'll send 7 y's outside the root, won't it? So we'll get y to the 7th outside, and we're left with the, well, here, let me clean it up. So we're left with y to the 7th outside, 1 y inside, 1 x inside. Now, we have one more step. We can't leave that root in the bottom. But is everybody good to there so far? Does that make sense what I've done? So I just subtracted the powers, leaving 15 on the top. And then odd powers, we write it as even with one more. Then the even, you cut it in half, because it's 2 for 1 deal at Target. 14 y's, you pay for 7 out of the root. Okay, now you can't leave the root in the bottom. We're fine with the root in the top, we don't care. But the root in the bottom is a problem. We can't leave that. So we come in and we go, okay, multiply top and bottom by root x. And so what do we get? Y to the 7th root xy on the top. On the bottom, root x, plain x, right? Because it's 2 in, 1 out. So it's y to the 7th root xy over plain x. There we go. Is that okay? Does that make sense? Questions I can answer? You getting all those rules down? The square root rules? No questions?